Hello, everyone. Welcome to this event organized by NLP DeepLearning.AI for NLP learner community. My name is Nikesh Bajaj, and I'm very excited to be your guest speaker today. So I'll start with my presentation for 15 to 20 minutes, and then we'll have a question answer session for the rest of the time. I'll be answering your questions on Slack. So don't forget to post your comment and question and upload the question on the Slack. I would like to thank you all to join this event. So let me start my presentation. Yeah, so I'll be starting with this. So the presentation, the plan of the presentation is that I'll start talking about how I started my journey to AI. Then I'll go into detail of my PhD work and current work, what I'm doing right now. And then we go to the question answer sessions. So I come from a very small town in India called Itarsi, and it's kind of a very center of India. I did my bachelor's in electronics engineering from IET. And in 2010, I completed my master's in signal processing from EMU. And since then, I worked for 5 years, almost for 5 years in north of India. And I started in AI in 2012 with the course, Andrew Ng's course, Machine Learning, which was on Coursera. I enjoyed that course very much. It was quite interesting course. And I still remember that it was the start of the course, Coursera at that time. We used to have the ml-.org as a link for the course. And it was so exciting that I still remember when they announced, the Coursera announced that there will be many more courses coming from any other university. Me and my roommate, we literally celebrated that news. It was so amazing that we will be learning now from many more professors. So that was my first course. Since then, I have done several courses from Coursera, Udemy, Udacity, and edX. So, and still I have been just doing many courses. Apart from that, I started working on some Kaggle competitions, though I didn't win any competition from there, but I learned a lot from that. It's a good point to start with also, because you can, in a course you learn and you start with the basic examples, and you can actually go to the Kaggle and you can simply apply those approaches to the real world problem. And in terms of learning, you learn a lot from many other people who are on the Kaggle, and they share their code sometimes, so you can see how they are approaching the problem. So you learn not a lot of new tricks and tips that how people are approaching it, people who are winning, what kind of approach they have. So it's kind of a very good platform to learn a lot of new things. So I participated in few competition. I didn't go further then. And then in 2015, I joined a PhD at Queen Mary University of London with the University of Genoa in a joint program. My thesis title was Predictive Analysis of Auditory Attention from Physiological Signals, which I'll be talking in detail in next slide. And during PhD, I was also involved in a lot of other activities, like I did the specialization from deep learning, for deep learning from Coursera. I attended so many summer schools, courses, offline courses, and gave presentation on the topics for AI and ML. And I participated in data study group, which is organized by Allen Turing Institute. And it's kind of a very good event where companies, they come and they post their problems, and there's a team of people who work on that problem. And at the end of the week, we show the one solution that we have. And I won also 2 competition as a second prize winner with a team. So there were a lot of activities I was involved with. In 2019, just last year, I finished my PhD in May and joined the University of East London as a postdoctoral research fellow, where right now I'm working. I'm working on a project called Deception Detection and Conversation. Well, the official title of the project is a kind of bigger, but the essence is the deception detection in a conversation. So that's what that I'll be again talking in detail, which you all might find more interesting because this is more related to the NLP that you all are already learning in the courses. So about my PhD work, the title was Predictive Analysis for Auditory Attention from Physiological Signals. In the whole project, we call it PHIAT as a physiology of auditory attention, because there is no much work about the physiology of auditory attention when it comes to the speaker attention to the speech rather than on the audio signals. So in this PhD, we designed one experiment. That experiment is based on dichotic listening task, where dichotic listening task is one of the famous experimental setting in psychology for evaluating the attention. So our experiment was based on that, but we didn't have the 2 stimuli for that. So experimental setting look like this model, where we have a listener, we have a different auditory condition, which we change for the auditory stimuli that we have. Auditory stimuli is just audio message. And we got 3 different kind of physiological signals, which is EEG and GSR and PPG. And we evaluate the auditory attention based on the transcription of a listener about the audio message. And the auditory conditions that we change are noise level. So we change the different, like background noise level as a crowded noise. What's the level of the background noise? We change the semanticity of the audio message. So audio message, sometimes it is semantically correct audio message and sometimes it's not semantically correct. And the length of the message. So these are the 3 different auditory conditions that we had. We were changing it and we were presenting it to the listener and we were recording all the signals. So from the experiment, we collected a data set conducting with the 25 subjects. We recorded signals, 19 stream of the signals at the rate of 128 hertz, 14 channel of EEG, 3 signals from PPG, and 2 signals for GSR. So collected signal looks like this picture at the right side. So it looks like it's labeled properly. So you can see that there are signals, all the signals EEG, GSR, and PPG, and this light green background is actually the listening segment. White background is the writing segment, and there is a resting segment. And for each listening segment, the attention score, which we calculated manually, is labeled for this score. So overall objective was to actually evaluate and predict this attention score based on the physiological responses. So as a label, we had every signal is labeled with the task, that what task the subject is performing, like listening, writing, or resting. And what auditory conditions are there, like what's the level of noise level, was that message semantically correct, what's the length, and what's the attention score. So from this collected data, we formulated 4 different predictive tasks. They look like the first task is kind of a very obvious, that we wanted to predict attention from the responses. So if you remember this model, so we want to predict this attention from this responses. That's what the first predictive task. Now our statistical analysis shows that This attention score depends a lot on the auditory condition. So for example, in a very noisy environment, attention score is very low. So this attention score is very much dependent on these all auditory conditions. So we had a kind of a significance analysis that which factor is affecting how much. But in practical situation, we don't have access to these conditions. So we formulated other tasks that can we predict these auditory conditions based on the task given by this. So can we predict these conditions from the physiological responses? And if we can, then we can actually predict attention from that prediction. So it's kind of like we can multi-level prediction and hierarchical prediction thing that we can use one prediction to predict another thing. So these are the different 4 tasks that we formulated. And all the resources, material, and whatever publication that we have till now, everything is shared on this link. We created this website where we have all the libraries and all the functions that we need to start with this. We have already provided some of the script that you can just start with playing around to see if you are interested in that. So this was all the PhD work. And currently I'm working on this project, which is called Deception Detection and Conversation. So I'm working with the University of East London. We have partners like Intelligent Voice, Trainers, and this project is funded by Innovate UK. And so the problem with the deception detection is very specific in this. So the idea of project is that we want to detect the element of deception in a conversation where this conversation might be, let's say, the operator of a financial company and the loan applicant, or it can be any other situation where customer from the bank customer is calling to access his information or account detail for the bank. So there's an operator and there is a customer, and there's a conversation. So we just want to identify, can we find out that if the person who's calling or customer is being deceptive. So that's the whole idea of the project. What I like about this project is that in this project we are again going to looking into what's happening in the brain, because according to the linguist and cognitive psychology, there's a lot of things that goes in brain when you are being deceptive or when you are lying, and knowing those things actually help you to identify it. So there is a kind of a psychological compulsion for you to behave in certain way, choose certain words. So what I like about this project is that we are looking into, again, what's going on in the brain from what you are talking about. So the assumption here that if you're being deceptive, you will leak some information in your conversation, in your choice of words, in your way of speech and everything. So that's why I like about this project. So the high level idea of the project looks like this. So we have, let's say, the conversation here. We have the transcription of the conversation, and we have the audio. We go with the acoustic feature from audio. We go with the linguistic features from the transcription, and we have designed like some model to predict the score of the deception. So that's a high level idea of the project, and it goes much more detail into that. So if I talk about the simple use case about this project, it looks like this. So if you can see this script right now, so this is a conversation between a customer and operator. And you can see that operator and customer. So it's a customer calling to a bank and asking about the debit card information, his debit card information. And operator is asking, can you verify your debit card number? And he says, I don't have that right now. And it goes like that. So the first thing that we do is we identify the linguistic markers there. this is a list of 16 different linguistic marker. So in literature, there are many more linguistic markers, like negation is one of the common one, where we can see no, not, can't, anything which is denying is negation. And causation, where you actually try to define some reason behind it. So because, effect, and hence. And hedging is one of the interesting one, where you try to be not very certain about something. So where you try to not give the full information, try to be not very accurate about that. So that's kind of a hedging. And like maybe and I guess and about. So it's called hedging. There's a slight connection between the hedging and uncertainty. So that's the one of the markers. So these 16 marker and the detail of that, we have already one published paper on this. So I'll share the link. You can go through that. So here's one of the simple model that we presented in that paper. So in this paper, we just use these 16 linguistic markers and the sentiment of each statement. So you all are very well equipped with the sentiment analysis. You all have done that exercise in week 1, I guess. So here is a model, and this decision tree is like a very simple approach that you can see. Actually, it's simple, showing that how we are deciding that if it is a fraud class or it is a non-fraud class, and which feature is very important and all. So we combine both of the features here, and so the best accuracy we got for this particular approach was with SVM, 69% testing accuracy. That was our thing. Okay, so this is a link for the paper that you can see actually. So now, interesting thing is about this paper is that there are a lot of challenges in this particular project, and the challenges are first of all, the first challenge is that deception. It's not a very well defined concept. It's more complex than simple labeling of being deception or not. It goes a lot behind the one sentence. So looking into one sentence, you can't be just very sure that it was deception or not. So it has a lot of things which is going behind it. Another challenge is that ambiguity within the linguistic marker. So there's a marker called hedging, where there's a term about. So about is one of the hedging term, where if you say the exact sentence like, I have about $10 million, it's a hedging because I'm not being very precise about it. So I'm using about. But if you use about, let's say that we need to talk about it. So here about is not hedging, because here I'm not hiding anything. So there's a lot of ambiguity in the linguistic marker. So it's not like a bag of word or the list of regex operation that you can apply and you can get the linguistic markers. So there's a lot of context it need to actually you can evaluate it properly. Other than that, the most challenging thing in this project is the dependency of the area. Like, so this problem depends a lot on the context. So what context we are talking about? So is the context is for the financial services, or is it for the loan application? Is it a simple interview, job interview, or is it trial, like some criminal trials? And so it depends a lot on that context. And there are papers in linguistics that they suggest that the significance of marker not only just change in the different contexts, but sometimes even the polarity of significance changes. What it means is if there's a marker, let's say negation, in one context, if the negation is very high in a class A and very low in class B, which is significantly different. So if you change a context, it might, these not only just a significance, but it might just change the entire polarity. That negation in class A might be very high than class B. So it might just change the entire polarity. So it also depends on the incentive of being like, if you want to be deceptive, what is the incentive that you will get, or what kind of penalty you will have. So let's say that if you are playing a game and you have to be deceptive, for example, there's a very famous game called Mafia, where you have to be deceptive. And there's an online version of that called Mafia Scum. So you have to be deceptive on that. So in the game, if you are being deceptive, then incentive is that you will win, and penalty is that most you will just lose a game. It's just a game. But if you're talking about the loan application, there's a penalty and the incentive is different. And it goes even to the extent that if you are lying on a trial, so it's a life and death situation where the penalty and incentives are very different. So different penalty and incentive actually trigger a different stress response of every marker. So it's kind of changes a lot of thing. Other than that, there's it also depends on the media of communication. So in particular, this project, we are working on the conversation, but conversation can be oral conversation or the written conversation. Now, even in oral conversation, is it on the phone or is it face-to-face? Because if you're talking to somebody on face-to-face, then you might not have that much time to delay or think if you want to lie, or if you want to think about your answer, or if somebody is being deceptive. So person has to be like very instantaneous, right? And if you are talking on the phone, then you're not looking into the person's eye, and then you can actually have a little more comfort of lying. And if the communication, it changes from oral to written, it changes a lot of other things there. So for example, if you go from oral to written, and in written also, is it an email conversation, or is it a chat, online chatting, or is it a written letter? Then it everywhere it changes a lot. So if you're writing an email, you have time to proofread it. You can read it again and again and think what everything is meaning and how it gonna affect anything. So you have time to redo your email, and you can think about it and properly write it. So email is more prepared one. Online chatting, you might not have that much of delay, but still you have a little bit more delay than oral communication. And you might just avoid to answer that also. So online chatting is a different one. And if you have, let's say, a prepared answer, that you might have seen that some of the CEO of the company, they have the well prepared answer for their interviews. They are kind of very, very well prepared, so scripted and kind of being weighted. Same goes for the politicians. So their communication has been properly vetted and prepared for the broadcasting. So they know what kind of words they should use, what kind of words they shouldn't use to avoid any kind of information or misrepresentation. So media of communication is another challenge that you have. So you have to kind of select one which you are actually working on. Then it also depends on every person. It varies in person, it varies in which region of the people that we are talking about, which language we are talking about, if person is a native speaker, or like me, the first language is not English. So if person is like that, so the use of language for the people whose first language is not English. If you are talking in English, then choice of the words are very limited. So you have a very limited vocabulary in that case. And then evaluating it against the people whose first language is English will be a little difficult, because the distribution of the data will be different. So there are a lot of challenges in this particular problem, and then you kind of have to choose a particular problem that if you want to use this context, this media of communication, this region, and this language. And then if you change anything, then a lot of things changes. So you can't actually just use a model trained on a one context and apply on another context. It gives you, it doesn't give you that good performance actually. So other than that challenge, now looking into these lot of scenarios that we have, the big issue comes with the data availability. So currently there are not many data set available in, for the deception detection. The one which is famous is the CSE deceptive speech dataset. It's a lab setting where interviewer and interviewee are there in the lab. They are like there's an interview conduction going on, and interviewee are being asked to lie about certain things. So it's a completely different context, and it's a lab setting. And there's another data set which is a mafia scum. It's an online chatting room. So it's again, it goes with the different context again. It's now chat room, and then there's the mafias who are trying to be deceptive. So there are not many data set available. That's another challenge for this particular problem. And the last, when you want to use this kind of model for any application like legal services or the financial services, and when you want to implement them into the system, you want these model to be very explainable, because you just don't want a black box just giving you prediction or the score. You also want to know that how it is predicting and which part of that it is predicting as a deceptive, so that they can dig into much more detail there. So explainability is another problem with the with such models. So these are the all challenges. I think I covered almost everything. So if you have any question, I'll be answering your question on the Slack now. So yeah, I'll be ready with the questions. All right, so there's a question from Richard Walker. He's asking, I'm wondering if Nikesh can talk about the involvement of signal processing. In what task is signal processing applied, such as translation, nervousness? Also, how can the data be related with the very small data set observation? And how is translation be done, existing framework? How important is a useful has this study signal processing have been these projects? So as much as I can understand, the question is that you're asking that how we can use the signal process, how we can use the signal processing for the application on the for the small data set. If you're asking the signal processing for the deception detection, or if you're asking about the signal processing for the auditory attention. So for auditory attention, I would say that signal processing is kind of a very much important, because when you're collecting a physiological signals, there are a lot of features that you need to actually extract from that, and there is a lot of noise. In particular in EEG signal, like electroencephalographs, there are a lot of artifacts that you have to remove. So in that kind of cases, when you are extracting such signal, they are always noisy, and it requires a lot of signal processing that you need. So another question is, how did you overcome the bias in the model? So I'm assuming that you're talking about the bias in NLP model, the model for the deception detection. Well, in deception detection right now, what the way we are working, the question was asked by Saurabh Tamle, and he is asking the question that how did I overcome with the bias in the model? So currently, the model that we are working on, they are, first of all, we don't have a large data set for that. So we have a kind of a limited data set that we are working with, and we are trying to generalize it. We are trying also to create new data sets. So bias is a problem that we haven't encountered yet, but that's one of the objectives to actually go into that. And once we identify what kind of biases we have, we might actually come for that solution. We haven't come to that solution yet. Right. So Shreya Sharma is asking a question that can you talk more about the explainability of AI, especially for NLP model? Yes. So for NLP model, there are a lot of explainability techniques for models, like when you go with the model such as BERT model or any deep learning model or any LSTM model. So there's a technique called the occlusion that's widely used. You can also use a method like lime and shape kind of tools that they can tell you much more detail about the input and output. The occlusion model is very approach is a very simple. Like you might have seen the example for images that they in the image, let's say there's an image and it's detecting face. So they try to hide a small part of the image and they try to see how much prediction value has been changed. And they keep doing it to identify which area is affecting the prediction score higher. And that area is being highlighted as a more important area for that particular image to be detected as a face. So a similar kind of model is used in the NLP approach. It's called the occlusion method again. So let's say that you have a sequence of words and a sequence of word, and you want, if you, let's say for the sentiment, there's a sequence of one tweet, and then there's a sentiment is 0.9 or 0.8. Then you go with the occlusion method and you hide each word, you remove each word, and then process it again. And then at the last, you see how much variation from the original sentiment value you are getting. And the words which are very much important for that sentiment, those words will actually be stand out. So yeah, there is a one paper on that, Explainable AI, which is from our lab only. It's on interspeech. You can go through that. It's a kind of a very good approach to go through the explainable AI for the NLP models. So there's another question with Richard Walker asking all usage of signal detection. So, okay, so you're asking about the all usage of signal detection in terms of your previous question. So yes, when it comes to the signal processing and signal detection, it's if you're in a very simulated environment, you might not get a lot of noise. But when you come to the like if you are capturing a signal from any device, then there are a lot of noise that you have to think about. Like even going for the communication system, we have a lot of noise in the communication that we have to overcome. So in terms of usage of all signal detection, there is no one method that we use for every particular area. There are different approaches. For communication, there are denoising methods. There are wavelet approaches to design. First thing that we do is we just filter out with the frequency band all the noise which is not relevant. Like for speech, we just reject all the frequency above 4 kilohertz. So which is not relevant for the speech processing. So in terms of signal detection, there are a lot of algorithm depending on the, again, area, which signal and which area you're talking about. So it goes, the approaches are different. There's another question from Rajan Garg. What are the steps we need to follow to start our career in NLP? Well, that's a very interesting question. So I think you're already in the first step, that you're already doing this course, NLP specialization, and this course is really very interesting. That even I have been working on this NLP project for last 1 year only. So I'm not very much expert into NLP yet. And I see still, I learn even a lot of things from this NLP specialization. So it's very good start for this project. I like in this course that you have started with the designing models from scratch. Not like you remember that you did the logistic regression, and then you did the probabilistic model, naive Bayes approach, and you are doing everything from scratch, which is very good to start with the NLP, and you have a kind of a very much grip on the what is going on in this area. So it's a very good start with the NLP. So Justin Mackey is asking a question: do you have opinion how large NLP dataset will be built in the future? Do you think the proprietary non-public dataset will give the owner a lasting competitive advantages? Well, yes, I think it's very very interesting question, that how large NLP dataset we will have in future. In terms of deception, there are the dataset which are even proprietary, and the CSC dataset that I was talking about, it is one of the dataset, but you have to buy it, so it's not freely available. And it will give a proprietary, it will give a lot of advantages to the company or the organization that is holding it. For example, if company is holding all the communication, and then they have they can build big models, and then they might not just release the data set, and then their performance, you can't beat their performance because they have the large data set. So yes, in NLP, it is again a problem that we don't, there are not many free data set, at least not in the deception area. So it gives you advantages if you have a big data set. Again, question from Richard Walker is: how important is physiological marker voice production in the deception marker? Well, yeah, we are also working with the voice and the text both, and the voice is again one of the important marker. Well, when we talk about physiological marker, it is a big area, but the voice is just a one. So physiological means you are evaluating, you are checking the skin temperature, heart rate, and other physiological responses. But when we're talking about only voice production, it's a different. So when you look into the text, you are looking into what has been said, and you are trying to evaluate the deception based on what has been said. So it is depending a lot on the choice of the words and the vocabulary. But when you look into the voice, you're not only looking into what has been said, but how it has been said. So it's kind of a very important to use this for the deception. It's very important. And as far as the other physiological signal and markers are concerned, like physiological signals, so this polygraph test, it is a very old technique now, and it uses a physiological measure for the lie detection. So it has been in the area for a long time now. So they detect the heart rate and blood pressure and the skin temperature and everything to detect if somebody is lying. Right. There's another question from Kartha. The question is, although deception cues are context specific, since we do not have enough data available, do you feel it makes sense to use the neural machine translation model on the just the text? I would imagine all cues in the audio be eliminated and voice translation process to help generate data set quickly to train the deception model in the other languages? Yes, well, your idea is very, very good, actually. It's very interesting. Yes, we can use the generative model to generate new data set, and we can use the GANs. Of course, it's a kind of a very good approach to generate new data set. And it's kind of interesting that I haven't even thought of that. So yeah, so given again for generating GAN, if you have a data in a one context, you can use it to generate a lot of data set. But again, that might be also in the same context. And then you might need to use some kind of transfer learning to transfer it into the one context to another context. But if you're talking about the other languages, I don't know how much difference is in the other languages. So for English, I don't know if the same every linguistic marker in English translated exactly same into the another language, because other languages have the different way of everything. It's not the word-to-word translation kind of thing. So it might differ, but it's a good approach to think about it. It's a nice one. There's another question from Rajan Garg. We are going through the algorithm, not much more in the reason behind them, but should we go much more in the depth about the maths behind them? Well, Rajan, I understand. I think that understanding algorithm gives you a lot of power over the algorithm, that how you can use it. I know that it's kind of a little common that to use the all algorithm in the bag and just use it, not to worry about the algorithm, anything maths behind it. But knowing what is in behind it will put you in much better position. So for example, now there are codes available and you can run hundred of different model from scikit-learn to Keras and everything. So let's say that if you go to the problem like Kaggle computation, you take one problem and you run hundreds and thousands of model. You run it on that, you write a script and you keep it running for 3-4 days. And at the last you will have one model which is working. It's a brute force kind of approach. But if you know which model, algorithm behind the model, then you can already understand that which kind of algorithm will work in this particular context and which will not work, which will put you in good position. Actually, most of the people, they can use it and they might not know why it's working and why it's not working. And if you know why it's working and why it's not working, it's more important actually. For as far as I think that it's more important for you to know which model is working and why it's working. And if another model is not working, why it's not working, you should know that, because if you are using this model. So another question from Shreya Sharma. Is a PhD or similar higher study mandatory for career in NLP? As most job internship and internship have as the prerequisite. Well, there are the job where PhD, I don't think the PhD is very much as a mandatory for the study, but if you are going into the sector like R&D where you have to do research, yes, I think PhD is very important, because in the entire duration of PhD, you learn to tackle one problem in much more detail. So you kind of develop a lot of skills about the problems and how to tackle it and how to actually handle it. So this will actually be very, very useful to have that for the R&D, but in many cases it's not. When you're just working, when you're not the core researcher, then it's not. It's okay to go with the master degree, and I think companies, they have been hiring people with the master degree also. So there's a question from Chris. Are you using some embedding like BERT or Robert in the project? Plus a bit later, could you please post a link of your paper again? Yes, so Chris, we are using BERT and the similar kind of models, and we also use embedding techniques. So for the many different approaches that yes, we use it. So yeah, I'll post the link for the paper later in this thing in Slack. Right, I think all the questions, I try to answer almost all the questions. If there is any other question, I can go. There's one question that I didn't answer. Richard Walker, what about the culture bias and mathematical bias? So I'm again assuming that you're talking about the culture bias in the deception. Yes, there is there must be, actually, as much as I understand, there should be in fact the culture bias in the deception thing, because we read in different culture it's different, right? So how you so yeah, so I personally feel yes, there will be culture bias, and once we come to that point, we will have to tackle that thing also. Yes. All right. There's a question on Paul Greer. Let me check it. Yeah. So the question from Paula is any comment on GTP3? I've seen some news about it and its capacity to understand the text and learn how to solve the arithmetic and simple auto completion. Well, I haven't used GPT-3, so I have no much idea about how it works exactly and how good it is. So no idea about it. Sorry, I'll try to read it, of course. Yeah. Right. Is there any other question? All right. I think I answered almost all the questions. All right. So I'll sum up the presentation, and thank you everybody for joining this event. And thanks. I'd like to thank Deep Learning and Alice in particular for organizing this event. And I'll try to answer your question on the Slack. If you have any other question, leave there, and I'll try to answer there. And thank you everyone.